this week's lesson is all about hexadecimal numbers. Now, we've looked at binary numbers and we've looked at our own decimal number system. The hexadecimal number system is just another way of counting. So it's very much like decimal, it's very much like regular decimal, but it's just got a different way of counting. I'm just going to talk you through this presentation first, and in the second video I'm going to take you through some examples, and in the third video I'm going to take you through 4 examples as well, just so you know how to convert between hexadecimal numbers and binary numbers. So just to recap about how base numbers work in general. So that number over there is the number 49. And how do we know this? It's because the 9 is in the ones column and the 4s in the tens column. So we know this as the decimal number system because every time we go up a column, we multiply by 10. So the decimal number system is known to have a base of 10. Each column can only contain numbers from 0 to 9. If a column had the 10 in it, we wouldn't be able to fit that in, would we? So we would have a 0 in one column and the 1 would move over to the next column. Let's say that we needed 15 units. We can't write 15 in the ones column. We would write 1 in the tens column and then a 5 in the ones column. You understand that, right? So this, for example, would be 9 ones multiplied by 4 tens. Sorry, my face is on that. And that would equal 49. Let me just move myself out of the way. There you go. And there you go. So you've got 49 there, made up of 9 lots of 1 and 4 lots of 10. So now that decimal is base 10, you by now should know that binary is the base 2. So each time we multiply our columns by 2. So the one column goes to 2s, then to 4s, then to 8s, then to 16s and 32s, 64s and 128s. We've been dealing with that from our past lessons. Each column can only contain numbers 0 or 1. That's it. There are no others. So in this example, we're going to count up every time it gives us 1 in the column. So there are 0 ones down, so we don't even count those, no point. There's 1 lot of 2s, and there's 1 lot of 8s. And that equals 10. Another way we can just 2 and 8. We already know that whenever we count it, we're just going to multiply by 1. So hexadecimal is a different way of going. Very similar to decimal and binary. This time the base is going to be something different. Now hexadecimal is a word that's split into 2. Okay? So you can figure this out. Hex, you might have heard of already. Kind of like a hexagon, which has 6 sides. Decimal, like our decimal number system, you think of the number 10. So hex plus decimal gives you 6 plus 10, which means that we are dealing in a base of 16 this time. The hexadecimal number system is comprised of 16 symbols, 0, 9, and A to F. The A to F bit, we'll talk about that in just a minute, okay? We use it to condense and communicate large binary numbers a lot easier. So whereas binary can only use 0 to 1, in hexadecimal, you've got 16 possibilities, which makes it a lot easier to communicate. So hexadecimal has a base of 16. So if we go back to our columns, that means that we go up in 16s. So 1 times 16 gives us 16. 16 times 16 gives us 256. And 256 times 16 gives us 4,096. Thankfully, we only have to deal with those first two columns, okay? So don't worry too much. Nice and easy, these ones, okay? So, like I said, if we were to have, let's say, the number 10 in our, 15 in our units column, we can't just write the number 15. It's very similar to this one. We'll go do that in just a second. Hexadecimal goes from 0 to 15. Like I said, we can't put 15 in the units column, so we're going to have to move that unit over into the 16s column. I'll tell you how that works in just a second. You can't put two numbers into one column. So instead of 10, 11, 12, 13, 14, and 15, we go to letters A through F. So don't worry too much about why that happens or how that happens. Just know that when you're dealing with the numbers 10, 11, 12, 13, 14, and 15, just know that there are letters that equate to those. So now instead of 15, see, we can't fit 15 in that units column. We use the letter F instead. So now we know that there are F lots of 1, which is 15 lots of 1. So let's say we hexadecimal number 7F. I'm just going to put that table up on the right hand side to make it easier for us. So we now know that F, if we look at our columns on that right hand side, equals the number 15. So we know that we have 15 lots of 1 plus 7 lots of 16s, which means that our hexadecimal number 7F is actually equal to our regular decimal number 127. Now in today's lesson, we're actually going to be dealing with how to go from hexadecimal numbers to binary numbers. So watch the next video to figure out how to do those examples.